Hello everybody, this is a presentation of our final Java course project. We did this project as part of our BSc degree. During the video we will see our game functionality. We will see that we can generate new mazes, solve them, getting hints for a solution, and setting up the properties. Using the properties we can define in which algorithm we want to generate the maze and solve it. For now, let's talk about the A-star algorithm. This is the solving algorithm that we implemented in our project. A-star uses a best first search and finds the least cost path from a given initial node to one goal node, out of one or more possible goals. As A-star crosses through the graph, or in our case the maze, it follows the path of the lowest expected total cost or distance, keeping a sorted priority queue of alternate paths along the way. A-star calculates the cost from the initial cell to the current cell. This is the meaning of the G function in the algorithm. And then it calculates the cost from the current cell to the goal cell. This is the meaning of H function. The name of H was chosen because it is a heuristic. Heuristic is a helpful solution measure that helps us to evaluate the cost from the current cell to the final cell. The lower the total cost is, G's and H's cost, the higher its solution will be in the priority queue.
Now let's begin a simple project demonstration. We start the project by starting the server. After opening the server, we'll add a new client. This is the home page for the client. Now, the first thing the client does is to generate a new maze. After the client asks for a maze, a session starts with the server. And after handling the client, the session is closed. The client can also ask for a hint. And the new session is opened. This method of communication prevents the server from being flooded by its clients. Now, let's add a second client. And this time, we'll set the properties for him. Let's ask, for example, to solve the maze using the A-star algorithm with diagonals. We would like to mention that every time a client generating a new maze and solving it, the maze and the solution are stored in the database. We use the Hibernate, which adds for us the ORM layer and that transforms a class to an object. Now let's solve the first client, maze 2. To the right, you can see all the communication with the clients and the sessions. Now let's close the server. And that's it.
Before we show you the architecture of our project, we want to explain what led us to divide the code to layers. So, we don't want to implement everything in one layer of code. We, for example, want to separate the user interface from the solving and generating algorithms. We don't want to depend on each other's work while making a project. For example, I don't want to wait for my partner to finish his part. This is just a waste of time. So separating the project to layers is the solution for this problem. This better separation can be achieved with the observer pattern. We decide on 3 layers: model, view, and presenter. The model and the view are both observables, and the presenter is being used as the connector between these layers. The presenter is the observer. Every time there is a change, the model and the view are notifying the presenter that a change was made. So the presenter knows what to do with the information he received. There are defined commands that tell the presenter its functionality. They tell him what to do. For example, send information to the view or the model, so they will know what to do next. Now, let's see that implemented in our code.
Here you can see the separation of the code to 3 layers. GUI as the view that is functioning as the user interface. Model as the brain of the structure, and the presenter that connects and combines the 2 layers. For example, let's imagine the client asks for a maze generation. When the generate maze button is pressed, it notifies the presenter and the update function is triggered. And the generate maze command uses the model. The model, first of all, compresses its unique properties and send it to the server. And afterwards, he waits for the maze from the server. We run this waiting in a thread, because we don't want to harm the user experience. We would like to mention that our code is also flexible. We created 2 interfaces, game board and game character. It is useful because if we want to switch our maze board to a chessboard, for example, all we have to do is to use the object adapter pattern, because both of the boards can implement from our game board interface. And after we finish talking about the client, let's talk about the server side.
As you can see, we also divided the server side to 3 layers, implementing the MVP architecture pattern. Now, in the myTCP/IP server, we open a socket for each client. We wanted to keep this class generic, so we get an instance of client handler in the constructor, which is an interface. This is one of our implementation of strategy pattern in the project. Now, last but not least, let's take a look on our implementation of A-star. The search function in the A-star class using a heuristic, which is an interface. Again, we use here the strategy pattern. We would like to thank our lecturer Eli Halaschi.
Thanks for watching.